Hey guys, so today hopefully I'm going to do a really fun video for you guys, and it's about what happens when you use those RCA repeater boxes. They have different names, and essentially they're Y-splitters. The idea is you feed in the output of a source like a radio into them, and then from there you can parallelize them into multiple amplifiers. Now, my hypothesis that I'm going to be testing today with the breadboard and the oscilloscope and everything for you guys is that when you use those, you actually have a problem with low in frequency attenuation. So what this means is that you're actually going to have a smaller signal at a lower frequency, like 10 or 15 or 20 hertz, when you use that versus when you use a line driver. And I'm going to try to test it out today and see if my hypothesis is correct. And before I do it, I want to state my rationale. Every single line output device, the WVC, a radio, a DSP, a line driver, has a built-in capacitor on the output of that specific unit. That capacitor, coupled with the resistance of the circuit from your amplifier, creates an RC filter, which has a negative 3 dB point attenuation, which means that once you reach that frequency, it starts to attenuate or lower the signal, anything below that. So my hypothesis is that when you have multiple amplifiers in parallel, that frequency goes up, which means you start impacting the audible range, or things that guys with low SPL systems really care about. So let me create the breadboard and we'll get everything hooked up and see if I'm correct. All right, guys, so the way we're going to do this test is super simple. We're going to use the quantisylum signal generator to push a signal into this breadboard. We're going to replicate the signal basically coming out from the DSP or the radio, and on the PCB board itself, it has these DC blocking capacitors. And after these capacitors, what I've done is I put in a load, and here we could see this is a 22K resistor, which basically mimics the load this particular source would see when it's connected to your subwoofer amplifier. This is pretty standard range. And now we're going to measure the voltage across these 2 points, which is essentially the signal your amplifier is getting. And we're going to measure it back with the quantisylum. And the goal will be to do a test to see if the output signal matches the input signal, and if not, how that behaves according to frequency. So again, the point here is that I'm trying to replicate right now is a single amplifier connected to your radio. So we're going to go into quantisylum, and we're going to run a frequency response test. We're going to do it at 14 dBV, so this is 5 volts RMS. This is maximum volume. We're going to do 20 hertz to 200 hertz, right? So this is low in frequency, very low in mid bass and subwoofers. And we're going to do 1 hertz per step. We're going to not plot it as gain. Let's plot it as dBV so we can look at the actual voltage, and let's let it run. So what you notice is, look at that voltage slowly creeping up. That tells us that the RC filter circuit concept is indeed working with these DC blocking capacitors. As frequency goes up, that voltage should go up. And yep, that's exactly what we see. So we could see the input level here does slightly fall off at about 100 hertz or so, right? So this is attenuating our lower end frequencies, and you could expect this on a standard DSP or radio, and hopefully the manufacturer compensates for it and you get a clean level signal. But now, really what I want to find out is what happens if I have 4 amplifiers connected in parallel with one of those RCA repeater boxes without active op amps or other line level controls like the DD Audio ZVL. Let's put these together and let's rerun the test. All right, there we are. So now what this means is, instead of having 22K ohms of resistance on the circuit, we only have 5.5 because we're parallelizing 22K. So I'm going to leave this graph up for reference. Let's go ahead and let's rerun it again. We're going to do the frequency response, same exact test. The idea is we want to compare. And let's watch that voltage, see if it's lower than before, right? The idea is, if my theory is correct, this is going to be much lower because our negative 3 dB fall off is going to be much higher. So we're going to have a higher fall off at a lower frequency, at a higher frequency, which impacts the signal that our amplifiers get. So let's add to the existing graph, and where's that graph? The moment of truth. Look at that, guys. Look at the amount of attenuation in the frequency range you care about, 20 hertz, 30 hertz, 40 hertz. This is all your subwoofer range here. If you use those repeater boxes or Y-splitters, this is what happens to your signal because of how circuits are built inside of the DSP. Okay? You have significant attenuation because that negative 3 dB curve has moved from somewhere down here in the 15 hertz range. It's moved, we could clearly see it at about 30 hertz now. Okay? I could do the math works out, but this is what I wanted to show you guys visually. You guys don't realize that when you use the Y-splitters or those RCA repeater boxes that are not active, this is what it's doing. You're literally creating a filter, right? Basically a high-pass filter, and you're attenuating your subwoofer signal. Hopefully you guys can take this into account and can, if you have this issue, rectify it. All right, so now that you're incredibly observant, what you noticed in my first graph was that the attenuation circuit not only impacts the actual voltage, but it actually impacts phase. So how are we going to show that off? Well, here's what I have. I have a signal generator up here on 2 channels, both of them at 20 hertz at 10 volts. Now I'm doing this so it's easy for us to look at the Oscilloscope in parallel circuits. One of them is same 4.7 microfarad caps as on the other one with the 22K ohm resistor. So amplifier 1, amplifier 2. For all intents and purposes, they're pretty much aligned. I'm going to be adding these resistors to create 4 amplifiers worth in parallel. Let's see if that shifts the phase of the signal at that frequency. And we'll play around with frequencies to see by how much, because technically, according to the math, it should. All right, so there we are. Who is surprised that we are shifting by a few degrees when we have this channel connected in parallel at 5.5 kilo ohms of resistance instead of 22? Well, nobody should be surprised because this is basic circuitry. All right, let's go ahead and play with the frequency. Let's bring it down a bit. Let's go down to, I know some guys are starting to play 15 hertz. You like 15 hertz. So now that we know that our filter is affected, let's go down to 15 hertz and see what happens. There it is. It's even more prevalent. So let's go up to 40 hertz. It should start to stabilize because we're above that negative 3 dB. Let me change channel 2. Go up to 40 hertz. See, now there's less of a difference. However, you could see that attenuation I was talking about, right? It's clearly evident. Let's go back to 15. Channel 1, and 15 on channel 2. There it is. You could see the difference in signal, right? That attenuation. We don't even need the THD analyzer. Simply see it on the Oscilloscope. At this point, you're probably saying loud fiat. If I don't want to get rid of my super nice looking gorgeous RCA repeater boxes, and I don't want to run an active RCA repeater, what can I do? I'm glad you asked, because the LF Audio wireless volume control here that I've designed that is coming out this month has compensation for this. Not only can it drive as low as 600 ohms with its dedicated PGA internally, it has gargantuan 670 microfarad output caps to make sure that if you do have low impedance, it has more than enough capacitance to make sure you never get this. I haven't talked about the THD ramifications of this in your circuit. I think that's too complex for this conversation, but just know that if you are to get the LF Audio WVC and put this before your splitter boxes, this will actually fix this issue. So make sure you reset your gains, because you'll be surprised at how much higher voltage you're going to be getting in your amplifiers and how much phase shift minimization you're going to have. So you're not going to have that delay that you're used to.